So I'd like to talk to you about the case when you're solving radical equations and extraneous solutions to radical equations. Now, in your mind, go back to chapter 8 when we were solving rational equations. Now, remember back in that case, it was possible for us to obtain solutions that actually turned out to be fake. We plugged them back into the original equation and oops, it didn't actually make our original equation true. And unfortunately, the exact same thing is possible in chapter 9 when we're solving equations that come to us with square roots in them. So let's consider the following example. We're supposed to solve square root of x plus 5 plus 3 equals 1. So let's go about doing that. Now, when we're solving a radical equation, our first step is to isolate the radical. Now, looking on the left-hand side here, the square root of x plus 5 is living on the left-hand side with a plus 3, who is outside of the root. So first things first, let's get rid of that plus 3 by subtracting 3 both sides. The result of that, x plus 5 square root will be all by itself, and then 1 minus 3 will become negative 2 on the left. Okay, now I want to pause right here. I want you to remember what a square root means. What is the definition of a root with an even index like 2? And then after reviewing the definition of a root with an even index, I want you to think if anything is particularly sketchy about this equation here. I'm just going to put a little flower next to it in case we come back to it. Now step 2, once the square root has been isolated, we very carefully square both sides. So we come in with our parentheses, wrap one big set of parentheses around the left-hand side, one big set around the right-hand side, and then apply an exponent of 2 to both sides. For the purpose of canceling out square root, square and square root will cancel each other out, and the only thing that will be left behind here, the square root and the square cancel, and so what's left behind is the radicand of x plus 5. Negative 2 times negative 2 becomes 4 on the right-hand side, positive 4, and after subtracting 5 from both sides, we get negative 1. Now, this seems like a perfectly good solution, but let's check this. Let's check. By plugging this back into the original, into the starting equation. So if I plug in negative 1 plus 5, square root of that, and root plus 3 equals 1, negative 1 plus 5 is 4. Now what is the square root of 4? The square root of 4 is 2. And so I have obtained 2 plus 3, but that's not equal to 1. So x equals negative 1 is actually a fake solution. And it has to be discarded because it didn't actually work and do what a solution is supposed to do. So let's discard x equals negative 1. It was fake, leaving us with no solutions left. We discarded the only one we had. Now the truth is that could be detected very early in the problem that was going to happen. That could be detected all the way in the back here where this flower lives when we were trying to solve square root of x plus 5 equals negative 2. When we defined an even root, such as square root, second root, we said that the square root is non-negative. The square root can only produce positive values or 0. the square root cannot produce negative numbers. So based on that observation, it's possible to detect all the way back here that there are not going to be any solutions to this equation because it's not possible for a square root to yield a negative number. So you can skip all this other work. If you remember the definition of square root, you can skip all this and say, hey, this is impossible. There are no solutions to this equation. Okay, so when solving radical equations, just a few things to keep in mind. First of all solutions must be checked. And not in any other equation that you have been messing with. Must be checked in the original equation. And second of all, if you have something like nth root equals negative number, and that n is even, such as n equals 2, that is impossible. An even root was manufactured to produce non-negative values only. And so if you find yourself with nth root equals negative and the index is even, that's an automatic no solutions. That's impossible. You can save yourself a bit of work.